Section 4.4. This section is about the probability. There are two types of probability. One is permutations. Permutation is, there are two requirements. One is order cons, and all the items are different, and is V-dot replacement. So order cons and V-dot replacement. Example, n different items are available, but only R of them is selected. So this is the formula for permutation, and this NPR is how to use the calculator to do the calculations. The second one is V-dot replacement. V-dot replacement is the same one, but is the second example. In this example, there are three letters, A, B, C. This is the way you could write it. You could write it in all these different ways. Since the order counts, so you have all these possibilities. Now, the second one is combination. Combination order is not important and is with replacement. So what is all the combination of A, B, C? These are all right. But since order is not important, all of them are almost the same, because as long as they have three letters of A, B, C, so the probability is 1. In the formula, you have additional R here. So that's the difference between these two. And here is how to use the calculator if you want to calculate NCR. So to calculate NCR, that's how to do it. So if you want to do the same problems, you type 3 first, and then math, and then PRB and NCR. For instance, on that one. Let's say I want to do this one first. I want to calculate R is 3 and N is also 3. So you go to math, and then probability, and then is this all right? But you have to put a number first. So in that case, you type your number first, 3, then math, then you go to probability. Now 3, and now you put your second number. I think we didn't put NPR. Let's try it again, sorry. 3, math. We need to have PRB, and then NPR, and then 3. See, that gives you the 6. So you need to understand that word to use NPR or CPR. C is combination, N is for permutations. Like for the second one, it said 3. Okay, you press 3 first, and then math, and then probability, and then NCR, combinations. And now you put your second number. That gives you the 1. Okay? All right. Now, these are the examples. There are a number of ways that 5-letter A, B, C, D, E can be arranged. So it's either 5 factorial, or you could use the formula. 5 out of 5. There are 120 possibilities. And it's V-dot replacement. Another permutations, this is combination examples. 5 letters of A, B, C, D, E is available and 3 of them selected. 3 out of 5. So there are 60 in this case because it's V dot replacement. In these examples, the tech company must appoint a president, chief executive officer, CEO, and the chief operating officer. So 3 out of 8. And order is important. So they want to have the president first and the chief executive officer second. So in that case would be NPR because its order important. Is first one is permutations. And the second times, there are 8 qualified candidates and they want to have the committee, but it's not important in the committee who would be the first, who would be the second. So the second one is combinations. And order is not important as long as they pick 3 people. A typical lock uses 3 numbers between 0 and 49, and they must be selected in the correct sequence. How many different combinations are possible? Order counts, but it's with replacement. It means you could repeat a number more than twice. So it's not neither permutation nor combination because it's violated one of the conditions of the rules. So in that case, if it's not one of this, to calculate is each time you pull a number, whether if it's number correct or not, probability of pulling the first out of 50 number is correct is 50 or 1 out of 50. What's the probability of pull the second number is a correct number? There are 50 possibilities, 1 out of 50, and then the third one. So it would be like 150 probability of the first number is correct, 150 probability of the second is correct, and 150 probability of the third one is correct because it's with replacement. So in that case, it would be 1 times, when you multiply this to 125. So not permutation, since the number can be repeated, is not combination because they must be in the correct sequence. In the history pop quiz, one question in which a student asked to arrange the following presidential order, they want you to have this chronological order. They want to have all this arrangement in order. If arrangement is in order, then it would be permutations. And when you do the calculations, remember this magic number. The probability, if it's less than 5%, is always unusual. Probability always has to be greater than 5% in order to be usual. This is a kind of permutation rule with the sum identical item. There are 10 questions. 2 of the questions are the same and 3 other questions are also identical. So in that case, this is a formula. N factorial and then N1, N2, N3. In this case, we have just N1 and N2. And that shows number of possibility. Probability is 1 over number of possibilities. With the jackpot, you need 6 different numbers from 1 to 44. And your number must match the same 6 numbers. The order doesn't matter, so it is combinations. In horse racing, selecting the horse that finished the first and the second, you must select those 2 horses in the correct order. Correct order means is permutations. 2 out of 20. And this is how to use the calculator again. You need to type 2 first, and then go to math, and then NPR, and then 2. This should be 20. A thief steals ATM and must randomly guess the correct PIN number. Its 0 through 9 must be entered in the correct order. So this one again is neither permutation nor combination. So in that case, you use the rule of 1 over 10, 1 over 10, 1 over 10 each time. This is a case that there are two types. One is you need to select 5 numbers between 1 to 59, and in the sequence, you need to pick 1 out of 39. So there are two combinations together. And why is combination? Because of the reason. Okay. Testing for the current in the cable with 5 colors. Again, this is combination because you could always replace it. This is a permutation rule again, where some of the items are identical. 10 questions, 2 of them are the same and 3 other questions are the same. Now, classical counting problem is this word Mississippi, letter S, what's the frequency of letter S? How many times is repeated? 4 times. I repeated 4 times, letter P 2 times, and M 1 time. So when you put all in this formula for this one, you get that number. So this one, you could actually calculate the factorial. You could just go ahead and calculate the factorial. How many ways can 11 girls and 3 boys arrange? Again, you are using the same formula. There are 14, 11, and 3. Lollipop is another example of this formula. A person playing poker is dealt 5 cards. How many different possibilities are there? There are 52 cards, and you want to deal 5 out of these 52. And its combination. This is another examples. Lady Antelope, 12 CD out of 27. It's a very, very large number. So it's a combination because you would always replace. The number is too large. This is very similar to the example that we had. You have to pick 4 out of 50, and it has to be in order. So it's permutations. Again, this is the examples. Number of ways that 2 events can occur. Given the first event can occur M way, and they say this is another formula for M times N. For 2 character code consists of letter followed by a digit. If you want a letter followed by a digit, what's the possibility of letter? There are 26 letters in the alphabet, and there are 10 numbers, 0, 1, 2, 3, 7, 8, 9. So it would be multiplication in this case. Now, we go to the examples, the first one on the homework. The answer for this one. And then number 2, the C is correct. Now number 3. Number 3, also we had the example very similar to that. ATM card must randomly guess the correct 4-digit PIN from the 6 code. So here, each time you press one key out of 6, the probability is 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. And remember, based on the example that we had previously, this for the ATM is neither permutation nor combination. So it's just a chain rule here. And then here, there are for these problems, Social Security number consists of 9 digits and repetition is allowed. After seeing the last 4 digits, randomly select the other digit. There is when you see this 4 digit, there are 5 digits left. So what's in this 5 digits, what's the probability the first number is correct? 1 out of 10. Second one, 1 over 10, 1 over 10, 1 over 10. So when you multiply these, what is the probability that the first 5 digits are correct? Is 1 over 10,000. Again, for this one, the name of remaining 3 students in spelling bees, probability selecting order and getting the order that is used. Remaining 3 students, so all the possibilities are 3 factorial is 6, so probability is 1 over 6. Radio station, call letters must be with, they want you to have the K or W first. So what's the probability of the first letter is K or is W? 26 and 26 because there are 26 letters in the alphabet. And then must include 2 or 3 additional letters. So number of ways is you either have K or W, so there are 2 possibilities there. The second one could be 2 additional letters. 2 additional letters is 1 out of 26, 1 out of 26. And when it's 3, you have 3 of these here. So the probability of K or W, there are 2 possibilities. It's either K or it's either W. You have 2 possibilities that the first letter is K or W. And then there are 3 other letters following that, but all is 1 out of 26. And then number 7, presidential candidate, is very similar to the example that we had. 3 out of 50 states. So 3 out of 50 states, it's permutations because you visit each state just once. Number 5, in the private school, 5 students are randomly selected and 16 are available. So it's combinations because order doesn't count. And this is how to use the calculator. Number 9, winning the jackpot. In particular lottery, you select the correct 2 numbers. Again, it's very similar to the example that I showed you earlier. But here is 2 out of 63. Two numbers out of 1 through 63. Number 10, With a short time remaining in a day, delivery driver has time to make delivery 5 locations out of 8. 5 locations out of 8. See, driver goes to deliver to a place only once, so it's no replacement. Order doesn't count. So in that case, is neither permutation nor combination. So 1 out of 8. Why is 1 out of 7? Because if I already delivered to one place, then there are 7 other places to visit. And then when you deliver 2 places, there are 6 places to visit, and so on. Number 11, we have 2 examples very similar to this. That's how you write it. This is an example very similar to the corporation that we had. The first one is permutation. The second one is combinations. How many different ways can letter of notebook is arranged? Again, you could follow this based on the other examples. Number 14, a game of jackpot. You peel 2 different cards from 52 different cards. The winning, like 1 of 4 aces and 1 of 16 cards with 10 points. So in this case, the very first one, what's the probability of pulling an ace? There are 4 aces out of 52, so 4 out of 52. And the second card is 16 out of 51 because you already select ace, 1 ace, so that would reduce the card to 51. So for the remaining, what's the probability of remaining 16 is from 51. So since you put 2 different cards, there are 2 cards. So you multiply that, well, this is the probability. And the rest is a multiple choice example that you have the keys at the bottom.